All right, scholars, so I'm going to do skill 35 mini lesson quickly. Mini means I'm not going to go over all details on it. Make sure you watch the actual skill 35 lesson to understand a lot of it. This skill is hard for a few reasons. Number one, we haven't looked at the trig function for a while, so you kind of forget all about it. And number two, it's kind of taking beats from here, beats from there, and they kind of try to combine as a one thing. So that's why it's confusing. Why are we making your life more miserable by doing something that's confusing? Because this is one of the skills that we got feedback from the calculus teacher that they really want pre-calc students to cover before coming into calculus. So that's why we are doing it. All right, so once again, it's going to be a mini lesson. All right, so let's just go back to trig world of y is equal to sine of x. Oh yeah, do you guys remember that? I do. All right, what does that look like? It looks like this, y equal to sine of x with a period of 2 pi, and it starts from 0, 0, and it goes like this all the way. You guys remember that? All right, what we're going to do today is we're going to do the inverse function. From Algebra 2 in first semester, you remember that the inverse means you switch x and y and solve for y. So we switch x and blah, blah, blah. It's going to be y is equal to inverse sine of x. So that's the inverse function here. And when you graph that, it's going to look like this. Okay, so the dotted line is y equal to sine. And this solid line is y equal to inverse of sine of x. Some of you will probably be like a red flag there, Miss Major. That is not a function. Correct. It's not a function. Why not? Because it does not pass the vertical line test. So what are we going to do? Give up? Nope, don't give up. We are going to restrict the domain y value so that it only has it's going to pass the vertical line test going from here to here. So we are only going to look at this yellow area and kind of disregard that. So what do I mean by only the yellow area? That means your y value is going to be restricted from, over here it's going to be negative half the pi to half the pi. Once again, for the inverse of the sine function, I'm only looking at the y value going from negative half to positive half. I don't care about the top part. So boop, that's the only part I'm looking at. So that's one piece of information you need to understand. Second, I go back to this inverse function notation. This is, guys, also same as arc sine of x. So these two represent the same thing. Both represent the inverse. Cool? Cool. Now, so this all represent inverse. What this is not equal to is the following. The reciprocal. All right, what is 1 over sine x equal to? This is equal to cosecant of x. So please know we are not doing cosecant right now. No. We are doing the inverse function, switch x and y. So that's the whole the note thing was about. Oh, my nails are dirty. Sorry, I was doing the yard work. So that's all right. I can't. Oh. That's the inverse we're looking at. We're not doing the reciprocal. So that's what today's lesson about. You switch x and y. Okay. All right. So that's what this part right here is about, the y value. Y is equal to inverse of sine of x if and only your y is restricting from negative half the pi to positive half the pi. We are cutting it up, so we're only looking at the, where is it? That much section. For y is equal to inverse of a cosine function, your y is going to be 0 to pi. In tangent, it's going to be negative half the pi to half the pi. So as you can see over here, so that is the y is equal to inverse of cosine of x, and y is equal to inverse of tangent of x. Notice your y value only this much, and negative half to positive half the pi. Oops, sorry. I'm sorry you couldn't see it. Okay? Also, this is about the all special triangle, blah, blah, blah. I think one of the things that can be helpful for you guys is kind of have this unit circle with you, because we're gonna need this when we are doing the problems on the next page. Okay. All right, it will make more sense once we do the problem. All right, evaluate the following: arc sine of -1/2. And you're like, what? Like, I don't even know where to start. Fine, I'll help you. All right, what you can do is just set it equal to whatever variable you want. You can do x, you can do h, you can do c for COVID. I don't know, whatever. I'm gonna do x. Are you guys good so far? All right, what does arc sine means? That's an inverse of it. So what this problem really is asking you is sine of x give you y value of -1/2. What is that angle? That's what it's asking. Miss Major, can you do that one more time? Sure. All right, what does arc sine means? That means the inverse. So what if I put it back to the original with the sign by switching x and y? So notice the x goes over here and the -1/2 goes here. So that's what this problem is asking you to do. Are you guys good so far? Yeah, hopefully, yes. All right, so we're going to refer back to unit circle. And if you guys remember that, this means it's a unit circle, okay? So is it fair to say that this problem is asking you which angle gives you y value of -1/2? Do you guys remember? Sine goes with the y value on the unit circle. So let's review that. Sine goes with the y value, cosine goes with the x value, tangent goes with x over y, cosecant goes with 1 over y, secant go with 1 over x, cotangent go with y over x. So that's on the unit circle, how to find those trig ratio. So once again, this is asking you which angle gives you y value of -1/2. So I look at it and I'm like, okay, y value. So I'm looking at the y coordinate. Where is -1/2? Where is -1/2? Oop! I see right here y value of -1/2, and I see right here y value of -1/2. Mrs. Major, this has two answers: 7/6 pi and 11/6 pi. Right? Because both angle gives you the y value of -1/2. No, you should only have one answer. Well, then how are we going to do it? How would I know which one it is? That's why this is important over here. The y has to be either greater than or equal to -1/2 the pi or less than or equal to 1/2 the pi. So on my unit circle, guys, where is -1/2 the pi? Where is -1/2 the pi? Oh, let's review. That's a 0. -1/2 the pi is negative, means you go clockwise. No, I can't do the direction. Yeah, clockwise. So that much is -1/2, and that much is 1/2 the pi. -1/2 the pi, 1/2 the pi. So we are looking at y value between -1/2 the pi, 1/2 the pi, -1/2 the pi, 1/2 the pi angle right there. So once again, which angle gives you the y value of -1/2? Whoop, 11/6 pi. Why can't I use that 7/6 pi? Because that's not the part of the y value. Remember, we are restricting the y over here. Does that kind of make sense? I hope it is. Let's do one more, a few more. Let's do this one, okay? All right, so I don't like it, so I'm going to set it equal to x or whatever variable you want to. So that's an inverse again, so I'm going to write it as a regular cosine function. So cosine of whatever is equal to 0. So this is asking which angle gives you, let's see, cosine is the x value of 0. Which angle gives you x value of 0? X value of 0, I have 1/2 the pi. X value of 0, I have x value of 0 right here, 3/2 the pi. Which one is going to be the answer? Well, you need to remember that table. Over here, for the inverse of cosine function, y has to be greater or equal to 0, less than or equal to pi. So how much is that? Greater than 0, this much, less than or equal to pi. So the answer has to fall in between these right here. So which one is going to be the answer? Right here, 1/2 the pi. Okay. All right. So that is that. Tangent is a little confusing. You might have to look at skill, I don't even remember, 34, that table, to see the tangent value. This one, what you need to do is, since it's in the cosecant, that's confusing me a lot. So write it as sine of inverse of -1 over square root of 2 is equal to x. And then write sine of x is equal to -1 over square root of 2, which that looks ugly. Well, excuse me. So make sure you rationalize it, and then that becomes a lot easier. Now you can go ahead and do it. Okay, so that's how you do the first part. Second part, evaluate the following, draw a diagram to describe the situation. So we're going to do inside, outside. Okay, you start from the inside. Right there. I'm going to let that equal to x. Are we good so far? Okay, so arc tangent of 3/4 is equal to x. A variable does not matter. You can use whatever you want. This means tangent of x is equal to 3/4. Are you good? Yes. All right, now we are going to draw a triangle. Since tangent is positive, I'll probably draw my triangle, right triangle on the first quadrant. Boop, boop, right there. All right, tangent is 3/4. We have to remember the SOHCAHTOA. This is a right triangle, SOHCAHTOA. Tangent is opposite OA, adjacent. So opposite side, 3, adjacent side, 4. How do you find the hypotenuse side? Yeah, that's going to be 5. You don't even need to do the math because that was one of the common triangle we learned. Good so far? Are you guys okay? Yeah, so that's the angle x. Boop. Now, what is the question asking you to find? Question is asking you to find what is going to be sine of that angle x. Notice the problem is not asking you to find the x. We're just going to use that x to find the answer. How do I find the sine? SOHCAHTOA. So opposite over hypotenuse, opposite side, 3, hypotenuse side, 5. Answer, 3/5. Are you guys good? Cool. Still a few more. Excuse me. That equal to x. So cosine of x is equal to square root of 2 over 2. We're going to draw a triangle. But when I hear this problem, I'm like sensing something. Do you sense something? That looks familiar to us, isn't it? Cosine of something is square root of 2 over 2. Cosine of something, that's the x value. What is the angle? Pi over 4. So I'm just going to go ahead and use pi over 4 over here. Because why not? I mean, you don't have to. But I'm just going to put. Okay? And I don't really need to do anything because then now the question is asking me to find tangent of x, which is same as tangent of pi over 4, which is y over x. X and y are the same value. So what is square root of 2 over 2 over square root of 2 over 2? 1. And if you did not recognize that was pi over 4, that's fine. All you would have done it is, that's the cosine is SOHCAH, adjacent over hypotenuse. So put that adjacent side as square root of 2, hypotenuse as 2. Then you're going to do that square root of 2, and then use those values to find OA, tangent opposite over adjacent. So it's going to be square root of 2 over 2, square root of 2 over 2. Excuse me, square root of 2 over square root of 2, 1. Either way, you're going to get the same answer, whether you recognize that was 45 degree or not. All right, let's do the last one, just because. All right, so I'm going to let that be x. So cosine of x is equal to -2/5. All right, this one is a little tricky because that cosine is in the negative value. That means your x has to be negative value. And so instead of my triangle being on the first quadrant, I'm going to draw it in the second quadrant so that I have a negative x value. Are you guys okay so far? All right, cosine is adjacent over hypotenuse. So adjacent side is 2, hypotenuse is 5. Pause it for a second. Where would that negative go? Adjacent side. So I'm going to put that -2 over there using Pythagorean theorem. Find the other side. Square root of 4, square root of 21. And no, be careful, check whether it's a positive or negative. On this one, it's going to be positive since it's a y, positive y value. Now I need to find cotangent of x. Let's see, think. Cotangent is reciprocal of tangent. Tangent is adjacent over opposite over adjacent. Reciprocal of that, ow. So adjacent side, -2, opposite side. Square root of 21, reciprocalize it. -2 square root of 21 over 21. Cool. All right, so that's how it's being done. And I think you guys can do the IP. All right, good luck. Bye.